Welcome, dear students, to uh, the interesting videos in Maths Mind. That is the videos dealing with the ideas. That means we'll be looking at very familiar examples to reinforce a particular mathematical concept. And in this video, we are looking at the identity function. That is uh, the rebounding of a tennis ball. I mean, that's the thing which we will be looking at, the rebounding of a tennis ball off the tennis racket. I mean, that process, the mass. So, the rebounding of a tennis ball and identity function. So, in that, and this, if the rebounding process can be considered as an identity function. Is there anything in that rebounding action which can be considered similar to an identity function? That's the thing which we'll be looking at. And before that, let us briefly look at what is meant by an identity function. Of course, it's quite simple. It's one of the simplest functions around, in the sense that it's f of x is equal to x, which simply means that uh, we are getting back or the output value is exactly the same as the input value. That is so it simply means that f of 9 would be giving 9, f of minus 3 would be giving minus 3, f of 2.7 would be giving 2. So such functions are called identity functions, because as far as the process which is carried out on the input element, input variable x, doesn't alter the value of the the element, and of course, what it means is that we get the same value. The output is having the same value as that of the input. That's a key aspect. And looking at if you look at that as a machine, so if the identity function can be looked upon as a machine, it's quite simple, in the sense that one may feel that the process which take place, so if we are looking at the whole thing as a machine, you can see that actually no process is taking. You ought to, we are forced to think that there isn't any process taking place here, or the process is absent, in the sense that if the input value is let us take it as c. If the input value is c, we get the c as the output value. So that's the thing is that it looks like in this particular machine there isn't any process going on. That's exactly why we call it's called I of x is equal to x. That's another way of putting it. The output value is doesn't alter. Now, coming on to the particular example which we are looking at in this video, when a tennis ball rebounds off a tennis racket, now what happens to the particular, we are taking the example from simple physics mechanics of the racket. If you look at the characters of the ball, so if you look at the three characters, that is mass, velocity, and acceleration, you can see that as far as velocity and acceleration is concerned, after the rebounding process, so after the process, what about all the three after the process? That's what we are looking at. After the process of rebounding, we can see that in almost all cases, velocity is going to change. Acceleration of also is going to change depending on the angle in which is the ball is struck, based on the uh, speed or velocity at which the ball is struck. So, but it's quite common sense, and it's quite easily understood that mass will not change. So, in that aspect, we can see that if you look at the tennis ball rebounding off a tennis racket, you can easily see that uh, considering the mass of the ball which is being struck, you can see that the mass of the ball which uh, comes onto the racket is equal to the mass of the ball which is coming after rebounding. So that's the point. So the ball which I mean the mass of the ball which is being struck it's the same, and there's nothing changes with that mass. So you may consider that example, that simple example from the physics viewpoint, as that of an identity function. So simply because the mass of the input ball is equal to the mass of the output ball. So uh, it isn't very confusing. You can consider that aspect as an example of a, if the rebounding of a ball is considered as an identity function, as a function, then the mass aspect, the mass of the ball, can be considered as an example of an identity function. Thank you.